Hey everybody, thank you for being here. I just wanted to give you a very short introduction to Ilaria because I know her very well, so I don't know what to say. Ilaria is a really brilliant researcher I met a long time ago. She did a master in computational linguistics in Paris, then a PhD in AI, especially focusing on the semantic web in England at the Open University, and she is now building up her own group at the Free University of Amsterdam, where she's involved in one of the great programs around artificial intelligence. You know, it's great because it doesn't have artificial intelligence in the group, in the name. It's hybrid intelligence, and I think she's going to tell us how hybrid intelligence is about making AI collaborate with robots. So, thanks a lot.
Thank you. With humans, more than robots.
Oh, sorry, humans.
That's okay. Okay, good afternoon. Thank you for coming. It's my pleasure to be here. First of all, I do speak French, but I'm so rusty that I'll go with English. Just tell me if I speak too fast. I'm going to do a bit of introduction of myself. I mean, Mathieu did a bit of it, but I mean, my background, so what I work on is mostly on the crossing between knowledge representation and machine learning, and actually I have a stronger focus on knowledge representation. I do try to integrate a bit of cognitive theories, and we have lots of applications in mostly 3 areas. So one is the e-science. So what we try to do is we want AI to support scientists in their discoveries, scientific discoveries. I really like robots, so this is why I'm also part of the project I'm going to talk about. But I'm really interested in the brain of the robot. So how can knowledge representation support them in better achieving their tasks? And I'm also here because I work a bit, so mostly with Mathieu on these ethical aspects of AI. So how can we be more aware of our technologies and the consequences that the technologies that we develop might include. But so today I'm going to talk about hybrid intelligence, and I want to start a bit with a motivation. So hybrid intelligence is a new and emerging field, actually. We do have a conference that started last year, and it was really popular. So we got about 200 people coming. And so the current situation in AI, if you know the people here in the picture, I mean, you know, Elon Musk, he just got Twitter, and he canceled completely the main management board. So in 2015, that was already 7 years ago, he said, oh, my guess is that we will have full autonomy 3 years from now with respect to autonomous cars. So in 2018, we will have fully autonomous cars. That was a bit of an overestimate. And I mean, if we take Enrico and G, he said, radiologists or doctors are in great danger of being replaced by machines rather than their own assistants. And the same, I mean, it goes with deep learning. I guess you're familiar with deep learning, but lots of people are talking about how deep learning is going to take over our own jobs, and it's overcoming, it's doing better than our own human abilities. What is not really clear is why do we really need to replace humans? So we're developing these technologies, and we want them to be better than us in our capabilities, in our job, and we don't really understand why. So if we take a couple of steps back and we look at how science was approached since the beginning. I mean, I'm now talking about like the latest discoveries, but you could go back in time and track additional examples. Science has always worked as a way to extend human capabilities. So the steam engine is a typical example. It could augment the muscular power of humans, so we were not able to pull and push enough, and then the steam engine could help. Another example is the car, of course. So we couldn't go fast enough, but with the car, with the plane, of course, we can improve, we can extend our speed, our capability of going fast. And again, similar to the telescope, so that we are not able to watch that far, but the telescope allows us to go very, very far with our own vision. So maybe we need to think of AI in the same way we have approached other scientific discoveries. And this means that we don't want AI to replace or imitate human intelligence, because otherwise the flames would have probably looked like this, right? So we imitate how nature is, or like imagine if a plane was imitating a bird. But it would be better to not to replace human, because it would be like we try to really fit a nail in the wrong hole. But it's much better to think of an AI that collaborates proactively with humans toward a shared goal. So this is the whole idea of hybrid intelligence. This is a large project, actually. It involves, it's one of the largest grants you can get in the Netherlands. It involves around, I think, 6 main universities, but there's a bunch of other universities that are rotating around, and it's a 10-year project. So we just started in 2020, and we are good to go until 2030. So we have a long way to go, and we are still making baby steps now. So it's like now 2022. I'm going to tell you a bit on what it is about and what we've done so far. But there's way more to discover and to things that you might also want to collaborate in the future. So the main idea of why do we want AI and humans collaborating is, and the main motivation behind hybrid intelligence is that AI and human actually need each other. So we as humans have limitations in certain cognitive limitations, so limitations in certain cognitive abilities. We do have, we fail in stereotyping, we have cognitive biases, we have shortage of memory, so when we do very repetitive tasks, we make a lot of errors. So machines can help us supporting our tasks and our compensating our limitations, but we can do the same with machines. So machines have also limitations in certain abilities. They don't know how to generalize. I mean, again, deep learning is a typical example because they learn statistically, but they have very poor ability in generalizing beyond the examples. There's very little creativity. I don't know if you're familiar with Dolly. I think you might have seen this generative deep learning model that creates images if you give a text. So you give a prompt. Somebody has seen that? Okay. So if you didn't see it, you should give it a try. It's actually quite fun. I tried with my students, like students looking at an AI lecture, and then the output is just something crazy. Machines are not aware of societal values. This is really important. So we do operate in a society because we know what are the ethical and societal constraints and the norms and values that we share, and machines are not aware of that yet. And like as I said, they cannot deal with rare and unique events. So we can really compensate each other's limitation and extend our own strengths. So that's the whole idea behind hybrid intelligence. Then the question is, how can we build this intelligent system? How can we make this hybrid intelligent system? We want them to be able to augment rather than replacing our own intelligence. We want them to be able to leverage our strengths and compensate for our weaknesses. We want them to be able to adapt to different situations. I mean, it's a lot of challenges that we have. And we want them to be able to take into account these societal values that we also are aware of. So where do we start? The research agenda, so hybrid intelligence, is actually divided in 4 main challenges that we call functionalities or capabilities. It's easy to remember them as CARE, so that's collaborative hybrid intelligence, adaptive intelligence, hybrid intelligence, responsible hybrid intelligence, and explainable. And what I'm going to do in this talk is that I'm going to explain you a bit the ideas behind these functionalities, and also I'm going to show you some examples of work that we've been doing. I mean, I'm actually presenting a very large thing, so I've done very little in everything I'm presenting here. So if we start with collaborative hybrid intelligence, and we wonder what is it that, what do we need to collaborate as humans? And one of the things that we always do when we try to collaborate for a task is that we basically do mind reading all the time. So I'm collaborating with somebody, and then I try to estimate what this somebody knows, and I try to predict what they do based on what I think they might know. Do you know what this means? How this is called? This kind of process? You might have heard of that. So theory of mind, does ring a bell? Yeah? Okay, so I'm going to show you an example, and then I'm going to Hollywood.
Oh. Oh. So.
This is really fun. I mean, I watch this like 3 times per year, and I still find it funny. So we do this mind reading. We start very early. So we try to estimate what the others want to do based on what our knowledge is. And this is called theory of mind. So we want agents, hybrid intelligent agents, to have a theory of the world, so a representation of their knowledge and how the world operates, but they also need to include a theory about the other's theory of the world. So, this means that we need to increase the way we represent their knowledge to include also the agents that they are operating with, being human or other artificial agents. So, in the specific theory of mind, I mean, if you heard about it, it's mostly defined as the ability to attribute a set of mental states to other people. This includes intention, hopes, beliefs and goals, expectations. And then we do this in order to be able to predict, but also to interpret and maybe explain the behavior of the person collaborating with us. And here, I mean, the keywords are really the attribution part. So we do attribute mental states, and we do this to be able to predict, but also to explain what the others are doing. And we are not there yet. We don't have machines that are able to do that. I mean, we are trying to do that, but all the systems that we see around are very far from achieving that. Especially if we think of a collaboration between a human and a machine. It has been demonstrated that the second order theory of mind, so that's like I know what the other knows, can be useful in competitive and mixed situations. Competitive or cooperative, it's still a collaborating setting, let's say. And then what we want to do is that we want to extend beyond the second order theory of mind in order to have a hybrid system that actually supports humans in their task. So we need these agents artificial agents that collaborate with humans to have an understanding of what us as humans have as a representation of the world. So that's the main idea behind collaborative hybrid intelligence, and there's a number of challenges that come with this idea. So how do we move beyond the simple human in the loop? We need to aim for reciprocity. So there's theories, and we are actually collaborating with psychologists and human behaviorists that have been dealing with cooperation between humans in this project. We want agents to be able to perceive the social behavior of their collaborators, maybe in a mixed way, so using language, using vision, using actions. We want these agents to be able to communicate. So this is an additional challenge, and this communication doesn't have to come necessarily through dialogue. It can come through dialogue, but also through multimodal interactions. You might have an artificial agent that is not able to communicate through dialogue. We want them to be able to understand how actions can be done jointly in a team. So that's really, really important. This idea of operating together toward a shared goal is what really makes collaborative hybrid systems a bit, say, beyond the state of the art. And we do want them to understand what are the societal norms. So one of the questions is also how do we integrate these concepts of reciprocity and leadership and hierarchy, in-group and out-group favoritism. These are all concepts that come from the social science, and these are all concepts all things that we do when we collaborate with people. So I decide that I want to take part in one team and not another, based on all these factors, and we need to encode these factors also in our intelligent agents. And one effort that we've been trying to do, this is a couple of PhD students that are working on that, and they're like from both the social science and the computer science domain. So what they're trying to do is that they're trying to build a data set that describes situation where people choose their partners, so that's partner selection. So they are mostly trying to take out theories from social psychology, and then they are focusing on these dyadic interactions, interaction between two people, and they are collecting data about like audio visual data. And they've been testing about 300 participants, I think from the UK, if I'm not mistaken. They've been measuring their personality and the trust and the anxiety, for example, that they prove towards like social anxiety. And they've been given them mostly collaborative tasks that they needed to achieve. These collaborative tasks, they're specific frameworks that the social psychologists use in their experiment. And most of the time they involve games in which you need to share certain values or certain money with participants, and then they try to establish what are the most important features for us when we choose a partner. So the main goal of this dataset is to try to, we are really integrating theories from social psychologists and techniques from computer science to try to understand and predict the interdependence between people in social interactions, and also to understand what are the social cues that we can then translate into an actual application, be it, for example, imagine a human-robot interaction or also a human-agent interaction. So this is an example of collaborative HI. And then if you remember, so that we go with CARE, so the second one is adaptive hybrid intelligence. If you recall, one of the main challenges of hybrid intelligence is we want these agents to be able to adapt to different situations. And if we now look at the current state of machine learning, or at least the data-driven, say AI, we are really behind in the sense that we cannot. These systems are not really able to adapt to changes in an environment. So you train your model over historical data, then you give new data which look very much like the historical data, and then your model makes the predictions. But if you give completely new data, it will fail quite miserably, I would say. They're not really able to adapt to changes in the team, so the environment we live in is really dynamic. So our agents are not really able to adapt to that. And they don't really balance between safety and reliability. And this is for most of the state-of-the-art techniques. I'm talking about transfer learning, multitask learning, meta-learning, which is this new popular framework where you try to create these models that learn directly from the metadata about the machine learning experiments. So it's really, I really like, I guess you know XKCD, right? And that's, if you don't know this, I really like this typical description on how machine learning works. So you just stir up a pile of data, and then you throw a result, and then, well, if it doesn't work, you just start again, and maybe it will end up working. I don't know if you ever try to do that, but I think it works 90% of the cases. So the strong assumption that historical data and new data are very similar is really it's not something we can rely on, because I mean, if this has led to very biased cases. I mean, I guess you're familiar with these examples where the software would try to predict whether somebody was a criminal or not, and then because the data was biased, and it's the data that is biased, it's not the model that is biased, so whatever garbage you throw in, the garbage throws out. So we can't rely on these for an adaptive hybrid intelligence system. Then the idea that we have is that maybe reinforcement learning can help, because in a reinforcement learning setting, what you do is that you try to adapt to the environment. So what happens is you first, the environment gives you an observation, then the agent performs an action, and the environment sends the reward, and independently whether the environment changes, the agent is still able to adapt his actions. So, and then I mean, the challenges that we have is that we want to move beyond this reinforcement learning setting in a way that is a bit more informed. We want to be able to learn reusable and safe behavior. So we want. And we want to do this in different ways. So maybe you can learn this in the reward or loss function. So you try to teach your agent, okay, you better not do that. We want to integrate this as symbolic constraints. So we really want to combine a symbolic and sub-symbolic AI method. Try not to do that, never to do that. We want to add this as restrictions in the exploration process. So don't try this. And we want we want agents to be able to learn this in a preference setting. So preferably try something. And also we want to try to optimize this, so trying to learn like in a sample efficiency, so with fewer trials. We're trying to do that. So when there's a set of PhD students that are really working on this idea of integrating symbolic structures in a reinforcement learning setting. And I mean, one of the key ideas behind the hybrid intelligence is really to integrate. So we don't only want to rely on statistical methods, but we want to include symbolic AI, and we want to include human values. So these are the three main component ingredients, if you want. And then, so this is just an example that a PhD student is working on. He's trying to learn causal structures. Reinforcement learning agents that needs to learn causal structures, and then the idea is that these causal structures are directly fed into the model, and by feeding these, basically the agent and the human have a shared representation of the world. So that these causal structures are a shared representation between the agent and the human. And then, of course, you train your agents with the goal of identifying structures that have not been encountered before. It's a synthetic reinforcement learning setting. This is maybe one of the main pitfalls of reinforcement learning, but you need to start from somewhere, right? And then the good outcome is that you can have a policy that learns both to perform informed intervention, so it's informed because it's informed from the symbolic structure, and is also able to update based on the training data, the estimate, the approximation that it learns about the causal structure. So this idea of I get a symbolic structure into my reinforcement learning setting can also be applied to knowledge graphs. I don't know, are you familiar with knowledge graphs? Like semantic web technologies at all? Have you heard of that? So this is my kind of hometown. So I see a thumb up. Okay, good. I mean, the main thing you need to remember about knowledge graphs is that they are like this huge amount of data that represent knowledge in a symbolic form. And then you have, most of the time, you have relationships between classes and represented as hierarchies. And what we try to do with another PhD student is that we try to use the hierarchical structure that we get from open source knowledge graphs. So this is free data that we get out there. We said, okay, why don't we take it and we try to force the reinforcement learning agent to learn from this structure. So basically, we use the subclass of relationship. So this is the hierarchy that we found in WordNet, Concept, and Wikipedia. So there's 3 different open domain knowledge graphs. And we wanted the policy to learn the abstract states based on the hierarchy of the concepts that the agent was learning. So instead of learning that this is a goat, it will learn that this is a mammal, but it's also similar to a dolphin, which is also a mammal, and these are both animals, for example. And we apply this in common sense text games. It's a bit better than a synthetic setting, but it's still very constrained as an environment. But what we've seen is that with the help of a semantic structure, so the hierarchy, we can have an agent, an reinforcement learning agents, improving and generalizing a bit better over the data, but also that we can, the agent needs less examples, so we improve on sample efficiency, which is really important because these machine learning models are really data hungry, so they usually need lots and lots of data to train on, and then of course we need to deal a bit with edge cases. So when it comes to open domain knowledge graphs, sometimes they get really messy. So you can get very noise or not enough knowledge because the knowledge graphs are incomplete. And we try to trick a bit the way the policy was learning. To try to remove a bit the errors in the training process. I'm doing well with time, kind of halfway. So if we go into responsible hybrid intelligence, this is where we really want to deal. I think Sarah is here, and she's also a guest in these days, and this is her kind of comfort zone. So we are talking about human values and how do we integrate that. This is what this functionality and this research line is about. And the problem is for those that are concerned with this responsible hybrid intelligence is that these days AI is being part of very important decisions. I mean, I've shown you earlier an example on how to decide whether somebody is a criminal or not, but I mean, it's the same whether you want to apply for a loan or these kind of things. This impacts both us as individuals, because my CV would get automatically rejected if I was applying to Facebook or one of those, because I never studied machine learning. So. And then, financial decisions or screenings of some kind, medical screenings. I mean, if I get selected for a clinical trial or not, that might be decided by an autonomous, like an agent, an artificial agent, and this is really problematic in some cases. And it also impacts us as a society, because sometimes, you imagine like fake news detection, hate speech detection. These are all things that can impact our lives. The Cambridge Analytica scandal was one of the typical cases. We don't really know why this AI takes these decisions. The reasons are really unknown, and we can't dispute them because we don't know where they come from. And whenever we have systems that come up with specific explanations, and we don't really know whether they integrate norms, values, and goals that we share as a society. So what we really want to do is try to move on from these. And basically, we want to move on from the classical approach, which is, the classical approach to this is that we try to encode actually we leave the human values implicit when we implement our agent. So what happens is that I'm programming my agent, and then the forbidden actions, so the ones that I don't want this agent to do, I just don't implement them. And then if I ask my agent, well, he actually doesn't know why I did that, why this was forbidden, he has no clue. So that's like implicit design, and then the norms and values and ethical issues, everything is in our head as developers. And then what we want to do is we want to move on from these and do a bit of more of ethics by design. So what happens is that I implement my agent, I implement the forbidden actions, and I let him know what are the forbidden actions and why these are forbidden. So the values, ethics, and norms are all moved inside the implementation of my agent, and the agent is able to then adapt his behavior depending on whether something is actually socially acceptable or not. So I think ethics by design is really the key word here. And then one interesting thing, again, to talk about this symbolic and sub-symbolic integration, argumentation theory. I don't know are you familiar with argumentation theory, or have you heard about this? It's a way of formalizing knowledge according to claims and rebuttals, things that support something. So you basically come up with a very symbolic structure around maybe a debate or a text or some amounts of data. So the argumentation structure is directly encoded in the system. So this ethics by design is actually, we use arguments and we tell agents, hey, look, this is the kind of structure you should be following. The argumentation is then performed by the system, but it can be extracted semi-automatically both by interacting with a human, for example, or by extracting these also through text mining, for example. So these are things that we are trying. And there are challenges in this direction as well, because what we need to make sure that we account for ethics during this computation. So yes, it's ethics by design, but how do we make sure that everything is going well? Therefore, we need methods to identify who are the stakeholders in an application, what are their values, what are their goals, what are their conflicts, and try to align them across stakeholders. And then we want to encode and model the model reasoning, our model reasoning in the agent. And we also want to related to adaptiveness. So we also want these systems to be able to accept that we as humans integrate additional norms and values at runtime. So when the agent is by interacting with the agent updates his information. So throughout the process. And talking about methods to identify stakeholders, one thing that we did is that I don't know if there's anybody that worked with knowledge engineering in maybe Mathieu probably, but so this is something that it's an idea that we literally fished back from the 80s, and we said, okay, let's try to see whether this works in 50 years later. So what we wanted to do is, so this common cut is a method that was used in knowledge engineering, again, in many years ago, to describe knowledge tasks and roles in knowledge-intensive processes. And that was not only to describe the system, but also to describe the entire situation around where a system was being applied. So the description of the organization, who were the people involved in using this system. So it was really a knowledge engineering process. But what this model would allow was to really model and design all the components and the relationships in a scenario. So we took this idea and we said maybe we can try to use this as a method to identify all the stakeholders in a hybrid intelligence setting. I mean, you might have a school, or you might have an hospital that is also involved, and we do have examples on these example applications. So, and then what we started working with this model, we came up with like a knowledge model for hybrid intelligence systems. So for every scenario that we were working on in hybrid intelligence, we started identifying common knowledge roles. So you always have an agent. It can be artificial, it can be a human. They have certain capabilities. It can be embodiment, it can be adaptiveness, I mean the functionalities in hybrid intelligence. They do certain operations related to information, so information processing. They need to exchange, they have a method to process this information, and they have a type of information that is being processed. And there's certain interactions that happen. So these knowledge roles were fixed. And then there were recurrent tasks that were happening throughout the application. So some were more related to classical AI, like recognition or recommendation, but some other tasks were really hybrid intelligence specific. So creativity, team awareness, and multimodality were, say, new tasks that our scenarios were able to represent. And with this kind of structured model, we then started really representing hybrid intelligence settings. So, for example, a mixed team performing manipulation tasks. So you need to read these graphics just as a set of inputs and outputs and a method inside and a task inside. So, I mean, your robot could be operating in that. And or for example, we could describe an artificial intelligence, an hybrid intelligent agent that was operating as part of a jury to take a legal decision whether somebody was a criminal or not. So this is a way to try to formalize and represent all necessary information from stakeholders to actual tasks in the responsible AI setting. And then finally, we have hybrid, explainable hybrid intelligence. So this is, I mean, you might be a bit more familiar. I don't know if anybody's working on explainable AI at the moment, like tools like chat. Oh, with you. Oh, it's good. We have a lot of things in common then. And then you will tell me if you agree with what I'm saying. So the current approaches to explaining models are mostly data-driven. So if you take things like tools like Lime and Sharp that try to tell you what is the most important feature in your classifier, or if you take examples like for classification images, they have these saliency maps that tell you what is the area that mostly contributed to a specific classification. Well, only this is really explanations that only developers can understand. So the users don't really get that, and we need users to be able to understand these explanations because we want their trust to use these systems. So we need to move from these data-driven applications to something that is more reflecting the way we explain as humans. And the way we explain as humans is using, well, background knowledge. Actually, this is my favorite example. Mathieu knows it by heart. It still works 20 years later. So this is the Google. Do you know Google Trends? You search for it. They tell you how much a term is being searched on Google over a span of time. And this is the search for a song in Ice and Fire. So that the term is a song in Ice and Fire. And then you see between 2012 and 2019, and then you see these regular spikes. And then if we want to explain why do people search for a song in Ice and Fire, does anybody have an answer? Yeah?
Seasons of Game of Thrones?
Yeah, and where do you see Game of Thrones in this picture?
8 seasons.
8 seasons, but I say the song in Ice and Fire. Yeah. so yeah, but what is the relationship between the song in Ice and Fire and
It's the book.
It's the book where Game of Thrones is, but you see how much background knowledge have you used for this? So you just said that people search for when a season of a TV series that is based on a book, which is actually the term that is being searched. So we do explain with a lot of factors and a lot of steps. And we do this in a shared way, actually. So the background knowledge is actually shared. So we all know that the Game of Thrones TV series, maybe not everybody, but some of us know that the TV series and the book are related. But we also know that it can't be a shower cup to be on the head of the queen. I mean, I should change it with the king now, but because probably the relationship between a queen and a shower cup is much more distant. There's less relationship between a shower cup and a queen than between a queen and a crown, because queens wear crowns. So we do use background knowledge, we do use common sense reasoning. So these are the two things that we use as humans to explain things. And what we really need to do is to have hybrid intelligent agents to do the same. So we want them to be able to do knowledge-driven explanations and then one idea is to use knowledge graphs for that, because knowledge graphs provide background knowledge and it's shared, it's public, it's there. The same way we did with hybrid, with the adaptive, with the reinforcement learning setting, then maybe we can use them for explanations. So then we have a number of challenges in these directions, because explanations, and I've been working on explanations for my PhD, so I can tell you, even before explainable AI was becoming a hot field, you need to be able to build faithful explanations. So you need to explain the mechanics of the model, but you need to be able to abstract a bit from these mechanics, and then you want these explanations to be rational, so there has to be a reconstruction that is faithful. You want the model to give a justification of the decision. You want this explanation to be contrastive, probably. So something happened instead of something else. And then you want this explanation to be social, because it's also important that an explanation is never generated per se, but it's also related to the goal of a specific task or a specific action. So all these are challenges. These are things that we need to face. And an example of this is something that I've been working on in the past, and that was toward this idea of explaining with knowledge graphs. And one thing is that you have a machine learning model that takes data as inputs and it gives you a symbol as output. And then you use a knowledge graph techniques or knowledge representation techniques. So you use a whole bunch of knowledge graphs that are available on the web, which is symbolic representation, to come up with an actual with a potential explanation of at least for part of your data. So that's one way of trying to achieve these more knowledge-driven explanations. And okay, so I think I'm going to kind of go very quickly here, because we are running out of time. These are examples of like how could we reach explanations using knowledge graphs for different examples. And then so we've been talking a lot about functionalities, but whenever we design a research agenda, we also need a theory of that behind. So what we've been trying to implement as well is also, we want to try to understand precondition, post-conditions, and the mathematical basis a bit behind our implementation, because otherwise we always do practice. I think I've seen something nice in your coffee room where you say, this is theory, this is practice, in this lab we do none of them. And which is absolutely true. So not for your lab, but in general. So we don't know why things work. And then doing a bit of theory behind your ideas also helps to understand why things work or do not work. So what we've been trying to do is to design some basic patterns for hybrid intelligent systems, and patterns are mostly intended as the same way I was showing you before. You have a task, you have certain inputs and certain outputs, and then you can have like basic patterns to represent symbolic reasoning, machine learning, training, or learning or from symbols. And then you can combine these into more advanced tasks, which could be anthology learning or explainable machine learning using inference. So this is really one way to try to represent your theory, structure your theory, and then you can then implement that into an actual system. So that was an example of that in a medical application. Let's just try to recap a bit. What is hybrid intelligence? Is this idea that AI should not replace humans, but should enhance our capabilities, as other scientific discoveries have done. And then we want agents to be able to collaborate with humans in a reciprocity setting instead of replacing them. And then the idea is to use these 4 research lines. So collaborative, where we integrate theory of mind, adaptive, where we use reinforcement learning, informed reinforcement learning, responsible, where we try to use this ethics in design by explicitly coding norms and values, and then using this knowledge-driven explanation in the explainable hybrid intelligence line. We've been through a number of things, so I show you how we try to design a theory of hybrid intelligence, how we can combine symbolic and sub-symbolic methods, how we can integrate human values into the AI capabilities. And there's an actual application that we really would like to work on, which is this intelligent agent that one day will welcome us in the lab, and the AI Einstein, we call it. Basically, we have this agent that over the weekend read all the papers that we didn't have time to read, and it says, hey, look, I figured that this is the next research hypothesis you should be working on. This is a dream, of course, but we're getting there, so we've been working on a bit on how to use AI to support us in scientific discoveries. And yeah, this is about it. As I said, it's a 10 years project. This is not only me, but there's about 6 universities, 30 faculties. We now have 30 PhD students, 20 more are coming between students and postdocs. So in case you're hunting for jobs, we are more than welcome to get in touch. For the rest, I don't take any credits in that, and I thank you very much.
Questions?
I told you I do presentations by intimidation.
Well, I'm going to ask a question then, because I'm not intimidated by you. Actually, it's a question I stole from a podcast I was listening to on the way to here, which is weird. I like when you say you need collaboration in HI, and collaboration should mean we should give the ability to artificial agents to understand human theory of the world. Doesn't it also mean that we need to give humans the capability to understand the agent's theory of the world?
Yes, partly, but on the other hand, so it definitely goes in both directions. But on the other hand, we also model our agent according to us, and we are not. So we're discussing this with. There's also a part of the project we are working with an animal behaviorist who, because they study how animals teach each other, and we want to see. We say, okay, humans teaching agents is maybe too ambitious because we have like different communication levels. And then we should lower this and try to use more animal teaching approaches, because we don't have that, and you lower capabilities. So the thing that we need to do is we need to proceed in steps. There will be a moment in which the agents will have their own representation of the world, but we are not there yet. And at the moment, the only thing we can do is encoding our representation of the world. I think maybe the best example is this one where we use the causal structure. So the causal structure is a good example where you really have a shared representation of the world, even if it's a very small causal structure. And I mean, the agent still knows the world as we look at it. And I don't even know whether we really want to get into a point where the agents should look at the world by themselves, because we never know what the outcome of this would be. So it should go in both directions at some point. And we are now at the stage, okay, basically it's the agents that look at the world as we do, and maybe there will be a point in which we can look at this in the other direction.
Cool. Yeah, it worked.
It warmed up.
The second question is always easier to ask, so I did wait the first.
I'm glad. But he knows that how to ask difficult questions.
So I did very much your presentation, especially stressing the complementarities between human and machines. Or I'm a lawyer, so my wording isn't approximate. And the result of that is making AI or hybrid intelligence more socially acceptable with collaboration rather than with replacement. So that's very good and very clever. However, I would like to question the word collaboration, because the word collaboration implies sort of partnership, if not equality. I collaborate. If I'm a legal person, I collaborate with another legal person or with a natural person. I don't collaborate with a tool. I might extensively say that I collaborate with my dog, which in French law is just a tangible thing and nothing more than that. So my question was, is collaboration between machine and or between the artificial intelligence and man the right word, or finally, isn't it about a collaboration between the user and the designer of the agent, or between the user and the promoter or the owner or the operator of the agent? So finally, couldn't we say that the artificial agent or electronic agent is just a sort of screen that's dissimulating either the persons who did train the agent or who operate the agent once it is trained? I'm sorry, my question was very lengthy.
No, I think, I mean, if I understood the question correctly, so, well, there's two parts of the question. On the collaboration term, I agree with you that probably depending on who you ask, so also within the consortium, there are people that talk about collaboration and people that talk about cooperation. And is it the same thing or not? I think we took the perspective of working towards a shared goal. And that's how we intend collaboration, even maybe it's not like the most, the best way to represent it. But this idea of having, like, working together towards something that we establish together and we know together, this is how we intend collaboration. And it would, I mean, we might change the way we define collaboration, like from a legal perspective, because you say I don't want to collaborate with my dog because maybe you know the ability and the cognitive limitation of your dog, and you currently know the ones of your artificial agent, but it might be what we really want to do is to have these agents which are a bit more, say, present. So maybe by integrating social norms and values that you might be more willing in 10 years to say I collaborate with this agent. So this is one part of the question, and the other part of the question where there is whether the agent is not a screen for the implementer. I think this is really where this ethics in design make your agent completely different. So we are now at the stage in which these agents are indeed the screen for the implementer. We do care about users, so we definitely want users to collaborate with the agent, and we can only make this happen if the agents know about the societal values we are operating in. So at that point, we don't care anymore about the implementer because the agent has, I mean, I'm not saying has his own mind, but at least has an entire picture of the way the world operates, at least. So this would be my answer to that. So by integrating human values and norms and values, we can move from this, yeah.
I was asking the question about the implementer because in terms of liability, if I speak as a lawyer, I need somebody to be liable. Yeah. And the liable person would be probably in EU law very soon the manufacturer or the designer, either the manufacturer of the tangible thing incorporating the AI. Or the designer. Yeah. There are draft regulations in Brussels about that. That's why my question comes from.
I understand, and actually, I mean, we do have a parallel project, which also, so we don't have lawyers in the project, but all the people working with argumentation have been working in the legal domain as well. So they partly know part of the problem. We do have a sort of sister project which is really involving philosophers and ethicists and lawyers, for which we are the use case. So basically, they're looking at the kind of disruptive technologies and their impact on society, and then hybrid intelligence for them is a use case. And indeed, we've been talking about liability. I also know from people working in the robotics domain that they talk more than talking about the explanation. They really talk about liability and responsibility of who is responsible for something. These are aspects that we will have to look at some point. But things go like progress together. So I think we got now into this the EU regulation, the GDPR. These are all things that came up as soon as we realized that our techniques were dangerous in some sense. And we need to evolve all these concepts all together, I think. So that would be a point in which you would say, okay, who is legible for, responsible for the hybrid systems that we are designing. We are not there yet, but I understand, thanks.
Hi, Ilaria. Thank you for the presentation. Ethics by design and embedding norms and values into the agents. I just wondered what your approach is going to be, or is begun to be already in this, and how will it work in terms of agents that are less interpretable and have less potential for explanation? And will it be a more negative approach? For example, restrictions, you can't do this, don't do this, whatever, or is there some positive element to it potentially?
I mean, I think so there's people that are already working at the moment. One of the techniques that is mostly used among the people working on the human norms and values is they're trying to extract this from information that is available. So one of the most popular techniques is through text mining. I think there's a couple of works that show how to do that in the proceedings of the first conference that we had in June. So what they do is that they try to through topic mining, maybe and from Reddit or this kind of fora, extract text and then approximate and try to get specific values. So this is one direction that we're taking. One thing that that I really like, but I didn't have time to form this idea yet in my mind, is that some years so in ontology engineering, you can use ontologies to abstract a bit from the actual systems, and then you sort of create a layer between the systems and the human users. And we use this together, if you remember, Matthew, we use this on robots. So we try to create an ontology engineering layer for users that didn't know robots to be able to implement that. And I had in mind, I was discussing with a PhD student working on these human values and coding them on doing something similar in order to so we create a layer where we represent human values, and then we try to link that to specific applications. So this could be, and again, I didn't have a clear picture of how this could really work, but this could also be one way of having systems that integrate this value. I think the most important thing is that the human values always come from us, so we need to feed them to the agent somehow, either, as we said, either through interaction or through extraction. Or through like ontologies and stuff. And then in terms of, I think the other part of the question was on the negative feedback, don't do this, don't try this, but I think this is actually, so the positive ones are already happening, do these, try to do that. And then we also want to integrate the contrastive part. So why you shouldn't be doing that for this reason and this reason. So they go together, I think. I mean, both as symbolic constraints or in the training phase. And I think we try to integrate the don't do part because we are at the stage in which they already know, okay, by implementing something, you're already saying, okay, this is something you should be doing. And we often overlook the negative, like say the negative ones. I would say.
Anything else?
I'm completely dry out.
Okay, that's a good thing to stop there. Thanks a lot, Ilaria. Thank you, everybody.